So for today, we are going to look into the topic of aerospace supply chain operation as well as management. So basically, this is one of the main topic that we need to cover because it is what the cost outcome number 3. Basically, at the end of the course, you should be able to describe the supply chain operations and management in aerospace industry. So the topic that we are going to discuss today will basically goes into the definition of what is a supply chain operations and what is supply chain management. There are a few examples that I'm going to share with you. So it will touch upon the basic production and operations management in aerospace industry. So just a principle of supply chain management, which also involve in material management, production and planning control, scheduling, capacity and facility planning, and finally, global management and operational strategies. Okay, if we look into the supply chain basis, if you are going into automotive industry or electronic industry, even telecommunication industry, of course we are now in aerospace industry, so the basic are roughly the same for the supply chain. There are 4 supply chain basics over here. The first one is we talk on the supply chain which consists of all parties involved. So basically it is sometimes called a complex network of companies that involve directly or indirectly in fulfilling a customer need in order for us to provide or produce a product, to deliver products. Most of the time in nowadays situation, the company are not just working alone in terms of providing or supplying parts before it is being handled by another companies, or receiving raw materials or process material, or providing services for the complete package. So it is a complex network, and normally it is being tiered. You have tier 1, tier 2, tier 3 from material suppliers, component suppliers, and there are processes involved in between, right? So that is the first basics. The second one is basically, if you talk about aerospace supply chain, it is an ecosystem of different supplier tiers. As I said, the first tier normally that communicate or have direct communication involvement with the OEMs. For example, like in the case of building aircraft, the structure of the aircraft. So we call for example, like Boeing as well as Airbus are the OEM, the company that produce aircraft. And then the first tier, we call it as the companies that supply directly to Boeing or Airbus, and it goes to the second tier that supply things to the tier 1, and third tier supplying things to the second tier. So in aerospace, it's always like that, where you have a tier system. And similarly with automotive, it is closely related to aerospace. And the third basic is basically includes manufacturers. The supply chain normally includes the manufacturers. It will also definitely include the suppliers, and is also include the transporters, the warehouses, and others. All right. And the fourth basic of a supply chain in aerospace is basically supply chain management refers to coordination of all activities from A to Z, from getting the raw material, having it processed, having it being cut or being mold, for example, to become the complete product. All right. So this is just the 4 supply chain basics when we talk about the aerospace industry. And at the same time, supply chain in aerospace impacts the entire life cycle for a particular product. If we talk about producing helicopters, for example, so from the early stage, the preliminary design of the helicopter until it is being detailed design, it is being tested by flight tests, pilots, and then delivered to the customer, having it maintained, and then the maintenance right after it, and maybe upgrading before it is being disposed. It is a complete supply chain of entire life of the product, from early conceptual design to high volume of manufacturing, and it involves all types of aircraft, all type of spacecraft even. So but there is a two different thing here. When we talk about aircraft, it normally have a very long life cycle, but if you talk about spacecraft, it is not meant to be repair. Nobody going to for example, send a technician to the space to repair the satellite. So it's basically, it is just one off. The spacecraft, the satellites that we send in outer space, basically it is just for one off. So it has a life cycle there, but it is not as long as the normal aircraft in place. So it involves the maintenance, repair, as well as the overhaul. Is also involves skills and talents. For example, like today in the aerospace industry, I got a news that there will be the last Boeing 747 being produced. If you still remember 747, it is one of the most popular air transporter before. It is since 1967. This Boeing 747 being introduced into the market, and the last Boeing 747 being produced today, from 1967 until year 2022, right? You can imagine it is more than how many years there? 37 plus 22 is roughly about 59 years since the first production of Boeing 747, right? So it is quite a very long time. It is quite a few generation over there, that people that work, maybe the grandfather work in the Boeing factory, and then the son, the father work there, the son work there, maybe the grandchildren also work in the same factory, and for a span of nearly 60 years. Okay, let us look into the right afterwards. I'm going to share with you about aerospace manufacturing supply chain, and the other part is on the MRO supply chain. So if we have already looked into the overview in terms of the general market of how these two giants, Boeing and Airbus, even though they are competitors, but basically they are complementing to each other, because if we just rely to one company to produce the aircraft for the airliners, it is not enough. So we can see that in terms of manufacturing new aircraft, there are surplus of around 1,600 new aircraft need to be built in the near future. And if you talk about general aviation, producing engines, piston engine, turboprop engine or business jet is roughly around 2,000 unit, and if we talk about rotorcraft, is around 1,020. This is data coming from the either the Deloitte report. We can also refer it to the PwC report that we have already discussed earlier. Okay, so if we look at the trend in terms of forecasting, this is coming from Deloitte analysis about for the aircraft going to be produced by Airbus and Boeing from year 2016 until 2034. So you can see that the number of aircraft going to be produced are increasing until year 2034 over here. This is about 2104. Basically, there are a huge backlog. Current situation, the backlog worth around US$ 800 billions. So we have already looked at the scenario where in year 2021, year 2020, there are a huge backlog because of the supply chain, because of the pandemic, because there's a hiccup over there. But now the industry are growing, and of course, it will affect the supply chain. How the supply chain for aerospace manufacturing for these two giants, the Boeing and Airbus, going to be successful, and how is it going to be developed, right? So there are many challenges in terms of aerospace manufacturing. For example, here, challenges in terms of producing casings and forging. We also have challenges for producing composites, auxiliary power units, printed circuit boards, actuators, software, high volume manufacturing and assembly methods, and many others, right? So because for example, like to build a new engine is not just one company, it's not just GE, it's not just Rolls-Royce, it's not just Pratt and Whitney producing their own engine. It is a collaborative effort. There are so many companies that participating in terms of producing one type of engine. Okay. And supply chain consideration and challenges can also be looked into this table. This is coming from Ernst and Young. Okay, it's Aerospace and Defense Age, Supply Chain Management in Aerospace and Defense, 2018 over there. So it can be break into several items over there. For example, like design and engineering in the early stage of the production. Okay, so consideration in terms of the timeline, the cost, the quality, the margin, the intellectual properties. For new technology, normally some of the IPs belong to certain entity. So they have to resolve in terms of to inculcate the new technology into the system. And then we also talk about efficiency, right? Before it moved to planning for mass production. Okay, you have to have forecast accuracy, right? So you do not want to produce aircraft parts before it is being ordered, and you do not also not ready to produce or to deliver parts and components. So it has to be balanced in terms of how many parts that you need to produce per month or per day in order for you to cope with the supply, to supply on time every time. Supply disruptions issues, okay, about maybe there are strategies not to having only one supplier for a part. So it is normally not a good strategy for a company to just rely on one supplier to provide a component. And normally they have redundancy. Maybe 2 or 3 suppliers or companies will supply the same things, so that they will not having supply disruptions. Demand shift, inventory, supply chain visibility, and lead times are also involved in considerations for the planning stages. And then when we go into the procurement, okay, to get supplier performance, to see whether a company that they have already provide a contract. Normally, aerospace contract is not 1 year or 2 years. It's meant for 10 to 15 years. Some can be renewable. So it is a practice in aerospace standard AS1 9100D that they have to assess the supplier performance. So price volatility, okay, cost and prices sometimes, especially for example, like in Malaysia nowadays, our ringgit are not that strong compared to US dollar, and mainly aerospace businesses are being conducted using US dollar. That's why the cost per component that being produced also being affected. They also talk about lead times for procurement, supplier due diligence as well, right? Because the supplier normally also being audited by the OEM. It's not by the higher tier 1 will audit tier 2. At the same time, OEM also will come to the suppliers to see how the component being manufactured, right? And where, what are the standards being used, and where the traceability of each component, even going into the material supplier, right? And then the process of manufacturing, we look into quality, because when we talk about aerospace is always associated with quality. Stock out, waste, capacity, cost, contract, safety, and volume. So, and when we talk about waste, how the all the chemical waste, all the metals waste, and other type of waste that being produced, be handled appropriately, because it is high in terms of the standards. That's why aerospace normally having high quality. And then we look into the aftermarket in terms of the supply chain consideration, right? So in terms of the ground time, on-time delivery network, as well as safety. So the item that being reported by Ernst and Young over here, and the challenges basically dependence on large number of sole source suppliers, long lead time. They also highlighted the financial challenges across the supply chain for new programs, and large inventory needs, collaboration across complex supply chain, cyber, and security as well. Okay, so, and if we look over here as well, this is also coming from Ernst and Young. So they propose a few strategies in terms of adoption of digital technologies, where you can look here. It is dependence on sole source suppliers, right? So the risk over there is moderate. Okay, long lead time, it is high risk. Financial challenges is low in terms of the risk. Large inventory, high risk. Collaboration across supply chain, high, as well as cyber threats is high, because you are going to adopt digital technologies. So they also provide the second strategy is risk sharing partnership. By having risk sharing partnership, it will have a low risk in terms of dependent on a sole source supplier, compared to long lead time, financial challenges, and large inventory, which going to increase in terms of the risk. Integration strategies, you can see here, they also provide the analysis, monitor security, cross-sourcing, multiple sourcing also can be conducted depending on the type of component that they are producing, right? So they also have cross-sourcing, okay, readiness assessment, and local players in supply network. So you can see here, it is a complex analysis and some of the strategy being used to consider whether the supply for each component going to be using different strategies. And this is a study made by Ernst and Young, okay, based on several companies in aerospace. If we look the map here, I know it is not that clear to see the map. It's just a map showing how the Boeing 787 supply chain network all over the world. As you know that Boeing is an American product, is not just being produced in America, right? 787 is not just being produced in America. It is also produce some of the parts produced in England, in UK, in Germany, in Italy, in France, Sweden, even in Moscow, Korea, Japan, and Australia. So, but most of it are being produced locally in the States, compared to different type of aircraft. For example, 737, they have a different distribution of supply chain. Similarly with Airbus, A380, you name it, A350 or A330, A320, they are having a different supply chain network all over the world. Of course, when they have a different suppliers, and each of the suppliers are also sometimes one component being produced by minimum two suppliers, so that it is not being reliable to any supply chain disruption. Right. Now we move into the next subtopic on supply chain. We want to look into the case of maintenance, repair, and overhaul. And global industry for MRO has already been reported by many consultants. It's worth more than $80 billion, and the network needed for the eVTOLs, electric vertical takeoff and landing. So and if we look here in terms of the MRO study, so the need of sustainable supplier, manufacturer, and MRO network, because maintenance, repair, and overhaul activities under the aerospace industry also highly dependent in terms of the suppliers, because you cannot do maintenance, you cannot do repair or overhaul without having the components being supplied. So because you need to get the manufacturer, you need to get the warehouses to supply the thing on time, every time. So there are issues on automotive companies also going into aero industry, right? And also issues in terms of the need to understand the production certificate, aviation grade, as well as the manufacturing needs. So compared to the aerospace manufacturing, MRO also having their own issues and challenges. Let us just look into the general overview. Just now we have already looked at the manufacturing and then a little bit on the MRO, okay? But I would like to also highlight the issues and challenges in general with regards to the supply chain. As we can see here, the supply chain can also be resulted from limited sources or sole sources. This is very high risk. So if you imagine you are relying to one particular company in a country to supply, for example, like the nose wheel for A320. So front nose wheel. So basically, if the company falls bankrupt or there are unrest situation, maybe there's earthquake, or there's war happening in that particular country, so there will be no company, there will be no nose wheel going to be supply to the market. So that this is also an issue. Some components, critical components, are also still being produced by only one company. So fragile supplier and market. Okay, there are many factors that we can touch upon fragile supplier, capacity constraint, supply market, issues in terms of the product security. Okay, some items in the aircraft having IPs that cannot be shared. So that is an issue because of the product security, foreign dependency. As we can see that example of 787, it is highly dependent from outsourcing. Many countries involved, diminishing manufacturing sources, material shortages. Some of the component require rare earth material, for example, so it's quite expensive, and some are very difficult to be produced. Gap in human capital. There are issues in terms of highly skilled people that being trained in one country. For example, some of the skilled workers migrate to another place where normally they go to. For MRO, they will the most popular venue is Middle East, because the pay is good, probably the lifestyle, the work packages are also good over there, and it attracts the skilled workers, especially the licensed aircraft maintenance people. They will go into the Middle East, and of course, this is the same thing, product security. Okay, let us look into more issues and challenges with regard to supply chain. The supply chain can also be affected by economy. Certain countries, especially right after the pandemic COVID-19, are still recovering, especially when we talk about Malaysia. Now we have a new government. It also affected the supply chain within Malaysia. Cost and taxes, right? Regulation and accreditation, purchasing power, market access, people, skills, and culture, the demand. Certain components having high demands, but certain components is not high demand because the parts in aerospace, it depend on the hours. It's not certain parts they require replacement within maybe how many hours of flying. Certain components, it depends on a longer period of time. Okay, waste and duplication, as well as offshore logistics and infrastructure. So that I would like you to explore. Later on, I will provide you with a few report that you can look into the more explanation of these issues and challenges that already being highlighted here. And in terms of supply chain strategies, this is a reference from a report, a paper by Hazer et al. 2016, Operation Management. So they come up with a few supply chain strategies to, for example, like the first one, to have more suppliers. Many suppliers compared to few suppliers, vertical integration compared to horizontal integration. They also look into strategies of having joint ventures, right? And this is another term called Keiretsu network, part of collaborations, part few suppliers, part vertical integration, and also a strategy using virtual companies. You do not have a physical company, they provide virtual companies. So let us move on into aero supply chain related issues, right? We have already touched on sourcing of raw materials, for example, like to get the aerospace grade aluminum, the steel, copper, and many type of materials. It is quite challenging because if you just simply rely on the suppliers to provide the same type of materials, you most likely you will be cheated in terms of some material that being bought from certain countries are not actually, for example, like when they say it is copper, it's actually not copper. So I personally myself, when we order, for example, we order aluminium 2024 from certain suppliers, and when we send it to Sirim, for example, to test whether is it true aluminium 2024 or it is not. So it's actually some of the product that we bought online. Sometimes it is not pure material. So it is a mixture of things. It's not 100% copper, which it's supposed to be copper. So in aerospace, they really pay attention in terms of the sourcing of raw materials. Okay. Mitigating supply disruption risk, geopolitical consideration is just an example how to mitigate risk. Later on, when we talk about risk, I will show you how we do risk assessment later on for aerospace industry, and coping with modernization and emerging technologies, especially now we are in the era of IR 4.0. There are a lot of automation, and some of the issues like wiring problems, software issues, late deliveries of laboratories, and many other things. Okay, so these are supply chain related issues, and it is also being reported here, shortage of skilled workers, right? For example, like Tim Cook's view on outsourcing, and this is taken from California Manufacturing Network 2018. Right. Recommendations, supply chain for urban air mobility. This is also taken from a report from NASA. This is a NASA study, right? So supply chain need to time to start building an entire new ecosystem. We are talking about future urban air mobility vehicles, UAMV, right? A new different strategy, different ecosystem of supply chain, and probably we can take advantage of other manufacturing, for example, like automotive, to rebuild the or train auto industry, heavy industries, or the traditional aerospace suppliers to consider the vertical takeoff and landing kind of urban air mobility. Because in the near future, we are going to see more and more the newly developed vertical takeoff and landing. Is no longer the traditional fixed wing takeoff and landing. Get regional manufacturing and supply chain associations exposed to emerging aero needs is also a recommendation made in this NASA report. Okay. At the same time, they also recommend build an electronic exchange platform to connect the vertical takeoff and landing customers with suppliers, like having prototypes, job production, mass production, quality management based on the FAA production need, and then they provide a recommendation in terms of the training workforce, either at the university or at the skill training institutions, with regard to the newly developed or revised curriculum, providing revised skill sets, as well as having entrepreneurships. Establish tiered system, because there's no clear supply chain for urban air mobility vehicles. Right, at the moment we have the standards aircraft manufacturers supply chain that dominate the aerospace industry. As of course, later on, for the new urban air mobility vehicle, they also need to establish the MRO network. Okay, immediate success, growing emerging aerospace system for the future. Basically, the effort to convert non-aero suppliers, because there are many non-aero suppliers. Okay, remember, any non-aero suppliers, when they want to go into aerospace industry businesses, the first thing that they need to do is to get the aerospace standard certification. The AS9100D is the passport for the non-aero suppliers to come into the aerospace business. At the same time, expand current aero suppliers and manufacturers in new areas. So if we look at the more than 18,000 companies that have already having the AS9100 and having businesses in the aerospace manufacturing, they can also expand businesses into other new markets. For example, like the urban air vehicles that we talked just now. See opportunity and identify areas to contribute and create a tiered system and electronic platform for the more advanced electric vertical takeoff and landing. It's no longer the normal propulsion system. We are now talking about clean, the green sustainable aviation. As a conclusion, when we talk about supply chain operation for aerospace, supply chain management for aerospace, we can conclude that build supply chain and manufacturing base for aero needs, particularly for emerging vehicles, right? So that can be concluded here, and to support the original equipment manufacturers, the OEMs, with supplier and manufacturing base and MRO. This is a strategy that any aerospace developed nation will have to pay attention, especially for Malaysia. They have to strengthen the supplier tier for manufacturing in Malaysia. Currently, support's already been given, but more focus on aerospace manufacturing, especially for the new technology that being used. For example, like 3D metal printing, which is quite new, that already being used by GE to produce their titanium blades. And increase production rate and delivery as compared with today's aerospace manufacturing and assembly state of the art. Okay, so because we have a very huge backlog, we need to find ways to modernize the production of the manufacturing process. Okay, parts access will need to be rapid for MROs, because the main issue for maintenance, repair and overhaul is to get the components, the parts that are required for repair. Okay, it's not like automotive industry. When you want to send your car to a workshop, you just send your car, and then the workshop will try to find the parts from the hardware shop. And it's not like that. For aircraft, maybe you have to wait for a couple of weeks. If you are lucky, maybe if you are the parts coming from, for example, it has to be shipped from France to Malaysia, so it will take some time to order. Some of the parts need to be manufactured in order for you to receive the parts for MRO activity. Okay, Build electronic platform and with authenticated parts and certified supplier and manufacturer base. Okay, because at the moment, of course, there are already system in place for suppliers for Airbus, for example, suppliers for Boeing, but there are things can be further improved to have electronic platform so that you can confirm to check whether one of the parts or the screw and nuts or whatever computer cards and so on are authenticated and it is a genuine parts and certified suppliers. And time to rebuild skills, talents, digital entrepreneurship, attract new manufacturer to scale deliveries are also among the strategies to strengthen the supply chain for aerospace. Right? So I would like to stop there